Hello, we are Team Sigma and this is Programming in FTC, Beginner's Edition. Introduction to Programming in FTC. What is an op mode? During an FTC match, a robot must accomplish multiple tasks and score points in order to get a higher rank. For example, for reaching a total of 71 points, a robot taking up a challenge in the Ultimate Goal season must place 2 wobble goals, shoot 3 rings in the top goal, and pump. For this, it must have a set of defined functions, variables, sensor values, and image processing. To make this easier, more convenient, and organized, there is a specific function called the operational mode, op mode, where whatever is present in this function will be run by the robot. What is Java? Java is a text-based, high-level, class-based, object-oriented programming language that has very few dependencies. It was created in 1995 by James Gosling for Oracle Corporation. It is very powerful and is used by many high-end programmers. It has multiple features like variables, functions, arrays, colors, conditional statements, loops, importing of libraries, using of classes, extensions, encapsulations, passing on variables, using return types, etc. Didn't understand a thing? Don't worry, we're using the FTC Bulletin Block software. What is that now, you may ask? The FTC Bulletin Block is a user-friendly programming tool that is run on a server generated by the robot computer. Its base is Java, so that it can control the rev hardware. Its development was supported by Google and is powered by Google's Blockly software. A user can create custom op modes with their own functions using this tool and save it directly to the robot controller. Users drag and drop MIT implementer-style jigsaw blocks onto a work area and arrange them in particular way with the library for carrying out functions, including logic and conditional statements. Let's now make the programs. So how to start with the teleop in Autonomous? So you have to start with the line-by-line flow of Autonomous program, which is basically an arrow representation of how your robot will run. That can be made on any software that you learn. Then you have to make the key algorithms. For example, image processing model, mechanism drive algorithm, and the parallel programming system. Now you have to merge all of these into your final op mode and run this into your robot. And you will get a total of your points. Here is how to connect. Turn on the robot by connecting the battery and flipping the powers. Open the Wi-Fi panel and connect the robot's network. Connect the robot's Wi-Fi from the phone and open the app FTC Driver Station. If you're not familiar with this or it's not available on your phone, it has to be done on a first FTC regulated mobile phone. Then check the configuration for the motor by going into the configure robot section. Now out here you have to set which motor goes where and what it's called. Now do not mess this up because this will show on your program. Then open the Programming and Manage section and find an IP address. Now this IP address will be very useful. Copy the IP address to your search browser and click Enter. Ensure your connection to the robot's Wi-Fi and then click on the Blocks tab. Create a new op mode, name it, and select Basic op mode. Then change it to Autonomous or teleop based on your license. Edit the block the way you want your robot to run, with functions, variable, math, and more. Once ready, don't forget to save op mode. On the driver station, which is your phone, select your desired program on the downward arrow for Autonomous, right for teleop. After that, initialize, then run. Enjoy your code being played. Now that was a bunch of puzzle words. You would probably would not know what that means. Anyway, let's get started with the programming. So this is our autonomous code. Now let's go into the key algorithms section. What are key algorithms? They are the functions that you need that you use during your autonomous and teleop period to earn a greater amount of time. Now, how do you initialize image processing? So, what is image processing? Image processing is taking and recognizing an image, and for the FTC, it uses Vuforia and TensorFlow. Vuforia is used for the image processing, which means taking the image, or taking the video feed or the image or the camera section or whatever, and then it goes to the TensorFlow. This TensorFlow uses machine learning to sense the number of rings. The rings can either be 0, 1 or 4, and this creates the specific location for your bobby ring. Now, how do you do this? Vuforia, first you have to go into utilities, Vuforia, optimize for ultimate goal, and then go to initialize with the camera direction or name. We have used camera name because that felt better. Now this is all in the library of first, which is very consistent. Our homemade TensorFlow and Vuforia models wasn't great, so we are using this for consistency. Now, after you've initialized it, you have to set the zoom, activate it, and finally, once all of this is ready, you can add data in the telemetry section. With numbers or text, whatever you find better. And what we have written is press play to start. So then it can be easily accessed on the phone or the drive station. Now ensure that you put this initialized image processing at the start of the code, and then call telemetry update. And then run on initialization is basically the reset position for all your servos and the directions for all your directions and modes for all your DC motors. Once you've done this, you can create a function called displayInfo and a conditional statement for if it sends 0 rings, 1 ring or 4 rings. How do you do this, you might ask? Let's see. So first you create displayInfo. First you create the function of displayInfo with a return variable of R. Now, what is a return variable? Imagine the variable as a box. Things from a box can be removed, put or seen. Right? So now, what is a return variable? A return variable is basically empty at the current moment, and it wants you to fill up the box so that it can use this value for other tasks. Now, so first what you have to do is create a variable and set it to 0. The variable is automatically created once you create the block. It cannot be deleted. All you can do is set and get. So now you have to call the displayInfo function, displayInfo, with I as index. So now what you have to do is increment the index. But how will I know whether it's 1, 4 or 0? So this is the else condition. If it is not 0, then it will go for this particular statement. So recognition is the automatic variable that is created for TensorFlow operation. If it's not created, you can go ahead and create it. Recognition will be the list, and recognition will be the variable that counts. Sorry, recognition is the list and recognition is the variable. Recognition is each index of the list. So, and recognitions is the list. So what is a list? A list is basically a variable that stores other variables. So now this list is what is required for a for each loop. So a for each loop finds each item of the list and carries it out, carries a certain condition or a certain statement for each item. For example, I have 4 items in a list. Now this for each loop takes all of these items and carries out a certain conditional statement 4 times. So if that made any sense to you, it will carry out the set index to index plus 1. So what is the current value of index to 1 greater. So it's basically index plus 1. And if the recognition is 1, it will carry this out one single time. And so index will be 1. If it's 4, the recognition the index will be added 4 times. Now the index will be 4. So index is always set to 0. Remember. And now in the display info function, you have to add the data or the number of items detected and now if you've gotten all of that, let's now go to the parallel programming system. Parallel or simultaneous programming system allows 2 motors to function together, saving time. Now how do we do this parallel programming system? So first you can call any function of the driving functions that you have. These driving functions are of course in relation to your motors. For example, forward is positive, positive, positive and positive for our certain robot. And we have a chain drive mechanism, so there is a lag between the motors. So we have kept power minus 0.2 to have the chain drive to work properly. Now instead of calling 2 functions before the wait block, you have to call a motor block, which is found in the actuator section, either in DC motor or servo. For example, while the glide left is happening, the shooter power is set to 0 and the target position and runner position are set. So the hopper's target position is set to 0. So both of these will return back to normal before the wait block. So ensure that you've kept the wait block after all of these to let your motors rest. And during these 2 during its life, these functions will happen. So this is a pretty easy one that's automatically set by the FTC block software. And now, thank you for watching. We'll now go off to tally up in the next video.